Hey everyone, it's Colin. I just wanted to do a quick review of a brand new multimeter that I just picked up. My old one didn't really have all the features that I wanted, so I went shopping for something that was a bit more full-fledged, kind of in the mid-tier multimeter range. What I ended up with was this, the Hioki DT4252. Hioki isn't that big of a name in a lot of the enthusiast circles, at least in the US. However, they are a big name over in Japan, and I think they're trying to make inroads into the American market. We'll take a look at this meter, its capabilities, and see if it's worthy of your consideration. So here's what you get inside the package. You get a set of test leads, the meter itself, 4 AAA batteries, which I've already installed in the meter to save time, and a user guide. The leads themselves are actually very nice feeling. They've got a really nice jacket on it. This is not PVC. I'm not sure if it's silicone, but in any event, it's very pliable, very nice to use, and I don't think it'll stiffen up too much when it gets cold. The jackets on both the banana plug end and on the test lead end are fully rubber. I know this kind of looks like cheap plastic, but it's not. It's actually very rubbery, nice strain relief on here. And a nice little touch that I noticed is that they include these little plugs to cover up the banana end for when you're not using the test lead. I think that's just a nice touch there. The actual probes themselves feel very good quality, fully rubberized along the length with the Hioki logo. This particular probe is part number L9207-10, color-coded, of course, and I believe these do conform to the new regulations about test leads. There are some new ones that took effect, I believe, in 2013, about having color coding and bicolor in order to show wear, if the wear on jackets or the test probes themselves. So you see when the second color shows through, that means you're getting down, deeper into the insulation. They have the fully shielded probe tips. This is also part of, I believe, the new regulations. And these particular probes are perfectly matched for the capabilities of the meter. On the probe tip covers, they're listed as being Cat 4 600 volt and Cat 3 1000 volt. And then if you yank the probe covers off, which is pretty easy, they're listed there as Cat 2 for 1000 volts. I really like the design of these probe tip covers. They're not overly bulky. They don't get in the way if you need to get deep into something, like if the lead you're trying to get at is fairly crowded. What's also nice is that the probe tips themselves are gold plated and they feel very smooth. I think they were nicely machined, not really scratchy or anything when you try and rub them together. I think you're going to get very good contact out of these. The probe tips themselves are fairly sharp. I don't think you're going to be, pricking your finger with these, but they should get to whatever test points you're trying to get at. What also comes in the box is a pretty nicely printed user guide. This is for the 3 different models in Hioki's kind of mid-range for digital multimeters. We're looking at the 4252, which they generally advertise as being a general purpose R&D lab use type of meter. The English is perfect. I haven't noted any sort of errors. And what I particularly like is the level of detail in this user guide. The entire thing is in English. It's not a multi-language manual, so the whole thing, almost 100 pages of it, is just about this meter in English. They've got a lot of specifications listed not only in the back in the specifications section, but also throughout the manual where it's appropriate when they're talking about the various functions of the meter and what you're able to measure and what you're not. Of course, the meter itself, upon taking it out of the box, I was very impressed with the build quality of this meter. It just feels very, very solid. It's nicely constructed, very good quality plastic. The jacket around the outside is not a very sticky rubber, but it's not a plasticky rubber either. I don't think I've seen this type of material before. I like the way the probe lead clips in the back work. They're very easy to get the probes into and out of. You don't have to struggle with it, but they stay in securely. This is actually a function that I will probably use. On my previous meter, I hated the way that the probe lead clips worked. I'm actually going to use it on here. The display lens is perfectly flat, so the amount of glare really shouldn't be too bad. compared to a meter with kind of a curved lens on the front. Nice indications all across the unit as to the functions. They've got the cat ratings, of course. This is 10 amp fused on the current side. The meter is cat 4 600 volt, cat 3 1000 volt. So like I said, that matches up with the probes perfectly. They didn't mismatch. They didn't just dig into the parts bin for these probes and throw them in the box with the meter. You can kind of tell they were really designed as a unit. Really nice range switch on this thing. Very solid, very clicky. It snaps into place. There's no play once it's into its position. But it's not too difficult to turn. You don't have to really put a ton of force into switching it around. Simple clicks will get you there. I also like that the very first thing that you turn to out of the off position is DC volts. I think for most multimeters that's what you should turn to, because it's honestly that's the most commonly used function on a multimeter. The rubber buttons across the top are actually not too bad. I'm not normally a big fan of these rubberized membrane buttons, but these actually are pretty well designed. They have a nice solid feel to them, a nice firmness. They're not too mushy, and you can tell when you've hit bottom and activated the function. On the back, you've got a nice solid flip out stand. This is not flimsy by any means. I mean, it takes a bit of force just to give it a little bit of a bend. And the stand angle, I think, is pretty solid. One thing that I did notice when first using this meter is if you're using it on a slippery surface, if you've got it on the stand and you turn the knob, it does want to slide around. On this white surface, I've got enough grip, but these two little points on the bottom of the rubber jacket are where it sits, and these can be a bit slick on a smooth surface. On the back, it's a single screw to get into the battery compartment. And one nice feature about this meter is to change the batteries or the fuse, you don't have to take the rubber jacket off. This was really well designed, and that the battery compartment fits perfectly around the jacket. The screw is captive on the battery compartment, so you don't have to lose it. And it goes into a metal threaded insert, so you don't have to strip out the plastic. It does come with AAA batteries in the box. I'm glad they went with AAAs instead of 9 volts, but I am a little disappointed that they went with AAAs instead of AAs. Here's the access to your fuse. This is a 11 amp 1000 volt HRC fuse. Looks like it's a decent quality unit. Very easy to access and nicely shielded around the side here as well. Also built into this battery cover and stand combination is this loop, and this loop is where you can put the optional magnet strap. Unfortunately, it doesn't come in the box, and I'm going to give this thing a little bit of a knock for not including that. It seems like a lot of the accessories for this meter are optional. For example, it's also got the data logging capability. These are your infrared transmitter and receiver functions. It's a separate module for the cable. Now, I will give Hioki some credit in that the optional module is native USB based. It's of course optical based, so you don't fry your computer, but the module plugs in and then it's a USB cord that goes directly into it. So you don't have to deal with one of those stupid USB to serial adapters. The cable also comes with the software. I don't have the cable and I don't have the software, so I can't review it. But at $100 for just that cable and software bundle, you're going to want to really think about whether data logging is important to you or not if you're considering this meter. Getting this jacket off is actually not too difficult. You simply put your thumbs in here at the top and kind of pry it back. And unlike a lot of other meters, I think this one actually doesn't look too bad when it's out of its jacket either. Let's take the back cover off and take a quick peek inside. One thing that I do like about this as well is that it's got 4 screws in the corners. That gives it a really solid feel. This meter does not flex at all if you pick it up and twist it. I should note that these screws, while they're high quality, are self-tappers and they're just going into plastic. That said, I don't think that's a huge deal on this meter because you shouldn't really ever have to take the back panel off of it too often, seeing as you've got access to both the batteries and the fuse through that battery compartment lid. That's why they put the metal insert there. Okay, one thing to note is it's a little difficult to get this fuse out. You need to lever it out under this end. That said, these fuse terminals in there are actually pretty solid. I wouldn't worry too much about that fuse falling out. And there's the back panel that comes off. Nice, just pressure contacts to hold it against the main board. Pretty nicely laid out on the inside here. They've got a number of screws holding this board down so it's not going to move anywhere. And the one thing that I should note about Hioki meters, at least this series and better, is that they make their own chipsets for their meters. They're not just reusing another company's chipsets. I know, for example, Sanwa, in their range along this series, they simply use a Bryman chipset. Hioki engineers everything themselves, so I think you get better quality. But the other thing about these Hioki meters is that they're supposed to be very fast. There's really nice blast protection around the outside of the back shell. It fits into this slot all the way around. Very, very nice and tight. I would not worry about safety too much with this meter, simply because it's just so well constructed. So you've basically got triple wall between the inside and the outside along this seam. They've got really nice isolation between kind of the logic stage and the input side. Let's get a little closer and take a look at that. So here's the input side of the meter. You've got the three terminals nicely screwed down. They've got the plastic wells with tabs coming up and over. Those aren't going to go anywhere. You've got a MOV here, a few resistors. Nice isolation slots cut in along this side here. Pretty impressed with that. And overall, I'm really pleased with the soldering quality on this. And you know what? I'm not surprised at the soldering quality because this meter and all of its accessories were made in Japan. Some of Hioki's lower end meters are starting to be made in Taiwan. This is one of their native Japanese made meters. So I really wouldn't expect anything less from them. Overall, I'm pretty impressed with the design of the input stage on this meter. I think it's very well designed and quite safe. This is something that I wouldn't hesitate to use with a high voltage application. And of course, that's reflected with not only the Cat 4 rating of this meter, but also the CE certification that it has. Let's take the shield off the back of the screen area here, and I believe this is where we'll find our processing circuitry. Okay, and here's what was under that shielded area. As I suspected, it's the full logic for the multimeter. We've really got two main chips here. We've got a TIM430F449. Not quite sure what this one does. I tried to do a quick search about it, not finding a whole lot in terms of data sheets. I suspect this is the LCD driver, but again, I'm not entirely sure. And then, as I also had on good authority, Hioki does make its own chips, and here it is. This, I believe, is the main processor for the multimeter. It's a custom unit, and of course, not only was the entire multimeter made in Japan, but so was this component. Okay, so we're all back together. Let's do some quick basic tests with the meter. Unfortunately, I'm not an actual proper EE. I'm just a hobbyist. I don't really have a full setup here. I don't even really have a lab. So I don't have a bench power supply, and I don't really have a bench reference meter to compare just how accurate this is against, say, a voltage standard. What I can tell you, however, is just how fast this meter operates, how smoothly it operates, and whether it seems to exhibit any sort of quirky behavior. I might as well give you some basic specs on this meter while I get set up here. It does have a DC voltage range of anywhere from 600 millivolts to 1000 volts across 5 ranges. On the DC voltage, its accuracy to within 0.5% plus or minus 5 counts. AC voltage, it's 6 to 1000 volts over 4 ranges. This unit does include a low pass filter, so you can cut out kind of the higher end harmonics. Where this meter may fall a little flat for electronics engineers is in its current measuring capabilities. This is their middle range. They consider this general purpose. It's only got two ranges of 6 and 10 amps. It will measure down to milliamps, but you won't get very high resolution out of it. If you want a higher resolution in those low current ranges, Hioki does have the next step up in this family, which is the DT4253. It costs about $180 to $190, and it does have a proper microamp and milliamp range on it. However, it won't go into the full amps. So if you need a meter that can do everything from microamps up to 10 amps, you need to step up to Hioki's high-end meter range or look elsewhere, because they don't have anything in this middle tier that will do that far of a span. This is a true RMS meter, and what I do like about it is when you're measuring AC, it's a dual line display. It'll show you both the voltage and the frequency on the upper portion of the display. So like I said, I can't really measure accuracy of the readings because I have nothing to measure accuracy against. However, we can at least see how fast it can take a reading. And I've got a fresh 9-volt battery here, so let's set this thing to DC volts. One thing that you may be seeing is that you don't get the best contrast off this screen at every angle. You do get better contrast if the screen is slightly away from you like this. You can probably see that better. That said, the meter does have a backlight on the screen, and that does help. The backlight has a default 10-second timer. However, if you start the meter while holding down the backlight button, set it into any range, you'll see it says backlight auto off. Then all you have to do is turn it on and it will stay on. That's a nice feature. You do get a full battery gauge up in here in the corner, and it's not just a low battery warning, it's actually a full 3-segment gauge. According to the manual, I have not tested this, but according to the manual, the low battery indicator will come on at 4 volts. So you've got 2 volts to play with. I think that's pretty reasonable across AAA batteries. They claim an average battery life of continuous use with the backlight off of about 130 hours. And for AAAs, with how easy they are to replace, I'm not going to complain about that. So here's a quick look at the screen with the backlight on. It's overall a very even backlight, and I appreciate that they used white LEDs. There are a couple of small hot spots down here in the corners, but in general usage, you won't really notice those too much. They're not bad. The screen has a nice overall even brightness to it, and it really helps the digits stand out very nicely. So here's our 9-volt. Let's just see how quickly we get a reading off of this meter. And you do get a nice beep when it detects the voltage like that, and then when it goes back to 0. You'll notice the bar graph down at the bottom. Both the bar graph and the display change very quickly. This is a fast meter. The beeper on this meter is actually very pleasant to listen to. I've listened to some meters that are really annoying. This one is not a beeper that I would complain too much about. Here's another little rig that I've got. It's just a pair of AA's and some holders kind of taped together here. Let's see if we get any different results with a slightly lower voltage. I don't think we will. And you can see we dropped into a lower range, so of course the bar graph is halfway across, and we're measuring 3.195-194 volts. This meter is specified for 5 updates per second of the screen. This is a 6,000 count meter, which is also really not bad for the price range. I think this meter, in its basic specs and functionality, kind of give Fluke and Agilent a run for their money. I believe this is better constructed as well. I just love the feel on this meter. So let's measure current so you can see exactly what I'm talking about when it comes to the limited use of the ranges here. So I'm just going to set up a basic circuit here. This is a blue LED. I've got the leads coming off of here just to make life a little bit easier. I'm going to put the probe into the correct terminal. Another minor drawback of this meter is that it doesn't have any sort of terminal monitoring or protection. So it is possible to have the probe in the wrong terminal and on an inappropriate setting, and it won't be able to really tell you in advance. There's no shutters, there's no optics within the terminals to, alert you as to whether you have them in the right positions. That said, these terminals are very solid feeling, and they are a solid metal tube. It's not a split piece of metal. I know a lot of people complain about those cheaper terminals. These are very solid. So let's see what we can get with the current testing, and I'll show you. I think I know what to expect. So there the LED has lit, and we're looking at 7 to 8 milliamps. If you need to see that this is 7.5 milliamps, 7.518 or whatever it is, this meter isn't the right one for you. However, for me, knowing that this is in the ballpark of what an LED should be, that's good enough. Another quick test we can do here is the diode test. It does supply 5 volts across diode, but strangely it'll only measure between 0.15 and 1.5 volts. So I don't think our LED test here is going to be too successful in terms of measuring the voltage drop across this. However, let's see if it lights the LED. And it does. It'll light the LED, but it can't measure it. So let's do a quick continuity test and see how fast this thing is. I noted that these have gold-plated tips on them and they feel very smooth. We should be able to get some really fast readings off of this. I'm curious as to how fast the audio indicator is compared to the display. So for real quick taps, the audio is very fast, but the screen is, yeah. You need about 1 second for the screen and continuity LED here to catch up. That's really good. Let's see how fast we can get this, figure out if this is latched. I think that's latched. On a non-latched meter, I'm pretty sure I'd get some scratchiness. Doing that. So that's a really good indication that they did some proper engineering on this meter. So is this meter really the perfect multimeter? Well, no, of course not. But at the same time, I don't think the perfect multimeter exists, at least not in this unit's price bracket. Generally, meters in this range, from the $120 to $140 range, have compromises of one sort or another. They may offer better ranges, but they may not be nearly as fast or not as accurate. They also may not have the safety rating. You could go buy one of the inexpensive Chinese multimeters and get tons and tons of features, but you're at higher risk of the thing blowing up in your hands, and that's really not something that I'm too interested in. When I first started sleuthing around to pick up a new multimeter, Hioki wasn't on my radar. In fact, I hadn't even heard of them. Now, granted, I'm sure some of the hardcore EE types that are watching this have heard of Hioki for a long time, and indeed, the company has been around for about 75 years. I just don't think they have that big of a worldwide, let alone American, market presence. They do have an American corporate office, which is nice because you don't have to worry too much about support with this meter. It does come with a 3-year warranty, and it has an accuracy guarantee for 1 year. The other thing that's nice about Hioki is they publish on their site that they try to keep replacement parts around for at least 5 years after they stop manufacturing a model. So even if your unit goes out of warranty but needs to get fixed, for a while at least they should have the parts for you. So all in all, is this the perfect multimeter? Well, let's be honest, in the $120 to $140 range, I don't think there is such a thing as a perfect multimeter. If you want to get something very close to perfect, you need to be dropping at least $500, and even then you'll probably find something to complain about. Really, when you're in this mid-range for multimeters, there's going to be trade-offs one way or another. In the Hioki sense, while you get the positives of very nice build quality, good materials, nice internal and external design. It's a very safe feeling multimeter. And I also like how fast it is. It is a little bit skinny on some of its features and capabilities, particularly in terms of measuring current. Overall, I think the 4252 is a great meter, especially for the price. I'm particularly impressed with the build quality. The feature set, I think, is pretty on par with other meters in this price range, but a lot of people may think this isn't a great electronics engineering meter, and for the most part, I'll agree. However, if you need to buy one meter because you're not going to use it that often, this may be the meter to consider if $140 is within your price range. If you like this video, please give me the thumbs up. If you want to see more, hit subscribe. And as always, thanks for watching.